Good evening, all. I hope my voice is audible to everybody. Students, I can see there are very less participate today. Please ask your friends to join the session. I request please inform your friends to join. Okay, we will start. Good evening, Shashank sir.
Good evening, ma'am.
Yeah, you can start for the day, sir.
Sure, ma'am. Yeah. All right. So let's start. So good evening, everyone. Yeah. So many good evenings. Good evening, guys. Yeah. Yeah. I hope you had a good day. Okay. So let us continue. So actually, we were speaking about some of the basic concepts. Yeah. Some of the basic concepts in NLP. So we'll see a bit of practical part also. Okay. So how we are going to implement those particular things as well. Okay. So first we'll directly start with the practical part first. Okay. So let me share the screen. So yesterday in NLP we actually discussed about this tokenization and stemming part. So first let us see those and then let us go to the discussion part and then we'll again go to the practical part. Okay. So let me share the screen. Yeah. Good evening, everyone. Uh, yeah. Thank you so much. Good evening. Yeah. Okay. Yeah. All right. Okay. So let us first see the tokenization part. Okay. So a few things in NLP we will discuss. Okay. These are some of the few things. So we'll go step by step. Okay. So first we'll go with the tokenization, then we'll go with the stemming part. Okay. So then again, I have a few concepts to discuss. Then we'll come back to the practical again. Okay. So like that, we'll be shifting between theory and practical for today and tomorrow. Okay. So once you got the hold of the entire concepts which are very important, then we can officially build an agent. Okay. So we'll be using some couple of tools. Okay. I'll tell you tomorrow. So if just do some research on that. Okay. I'll tell you tomorrow. I'll tell you in detail. Okay. So let us see the tokenization part first. So yesterday we have discussed about the tokenization. Okay. So basically tokenization is done for a group of words, right? So how we give prompts actually, right? So the same way, we give prompts to a tool, right? So let it be a generative AI tool or any kind of tool. We are going to give some prompts. And I told you how it is going to actually, do the analysis part of a prompt, right? So as a part of that, we had to discuss a few things, and the first one is basically a tokenization. So the basic tokenization is nothing but splitting the words in a particular sentence into words. So you can see here natural language processing is fantastic. Okay, so if you use a simple tokenization, okay, so if you use a simple tokenization, you can see that you just can have to use the split function. So this split function is basically a simple Python code. Okay, so it is not especially related to the natural language processing. So for natural language processing, we are going to use the NLTK library. Okay, so we'll use the NLTK library. Okay, so here if you see clearly that we are going to use the dot split function. Okay, so this basically dot split function will actually split the data. Okay, so it is going to split. Here we have actually given the word tokenization. So since it is a word tokenization, yeah. So since it is a word tokenization, okay, it is going to split into words. Okay, so if it is a sentence tokenization, it is going to use, right, it is going to use a huge sentence. Okay. For example, if we have a big review, right? So you want to understand or you want to analyze by a particular sentence or a huge from a huge corpus. Usually we say big text as a corpus. So we are going to use the sentence tokenize. But in this case, since it's a basic Python which we are implementing, we'll go to the NLTK part. I'll tell you that. So for a simple one, you can use the dot split function, but you have to give the delimiter. Here you can see dot in the bracket. So this gives the delimiter. So for example, between sentences, you will see which delimiter by which they are separated. You will see full stop, right? So that is what this dot is about. So this is a manual approach. That means you are giving a dot and you're saying that do the sentence tokenize using the dot. Okay. And for just anyway, defaultly when you say split function, it is try to split. But here we have given the delimiter. So now you can see that it has basically tokenized. Okay. So you have individual words. So now you can see natural is one word, language is one word, processing is one word, right? And in bracket NLP is one word, and is one word, and fascinating is one word. So you can see it being segregated. Okay, so this is how your generative AI tools will segregate, even your AI agents. Okay, even your AI agents, which take your command and it is going to apply this sentence tokenize or word tokenize based on the scenario or situation. Okay, so here we are trying to understand the functionality of AI agents and generative AI. Okay, this is very important in understanding an agent. All right. Now here you can see the sentence tokenize. Since we have given only one sentence, so it has taken the full sentence as one particular sentence. Now let us go to the very important part, which is the using the NLTK library. Okay, so this NLTK library is basically nothing but So the NLTK library is basically nothing but it is a library which is basically used for it is basically used for natural language processing. Okay, so the NLTK basically stands for Natural Language Toolkit. Okay, and this is one of the very important libraries, and you can see that you have a couple of important functions. Okay, which are this punct and punct underscore tab. Okay, so these are the two important functions which are existing inside I would say which are existing inside in a very simple terms, we can say inside the NLTK library. So these are basically modules. Now here you can see that if you want to apply tokenize, okay, by using NLTK. So if you are using NLTK, Natural Language Toolkit, so you have to use the NLTK library, and inside NLTK library you have one particular function which is called as tokenize. Okay, so you have to use the dot tokenize function, and you have two functions, which is the sentence tokenize as well as the word tokenize. So for word tokenizer, you have to use the word underscore tokenizer, that is the function. And for sentence tokenizer, you have to use the sent underscore tokenize. So these are the two functions which are basically used to apply the tokenization. Some sentences single programming. Okay. All right. So we are applying both the tokenizers here. Okay. So here we have a piece of text. Okay. So here we have a piece of text, and you can directly apply the sentence tokenize, and you can apply the word tokenize. Okay. So this is how you are going to apply using the NLTK library. So the first example was just using the split function, and by using a delimiter for a split function. So it is a basic Python, and when you use NLTK, we are using the natural language processing. So that is why I have put this example also to show you the difference between the usage of NLTK as well as the usage of a normal normal Python code. All right, and this is how you can see the sentence tokenize as well as the word tokenizer. Okay, next, let us do it using the Spacy. So Spacy is also one of the most important, it is also one of the most important I would say important libraries, especially inside NLP. Okay, so to read the text and to build a model inside a text. Okay, and you have a English model, or you can say an English, model. Actually, it's a model. To be fair, it's a small model which has the services. Okay, so this particular model, which is en underscore core underscore web underscore sm. Okay, so English underscore core underscore web underscore small model, actually that is. Okay, so that is one particular model which is existing inside Spacy, which is basically used for tokenizing. So now using that particular function, we are storing in that variable NLP, and we are applying that particular model. Okay, see, you can see here. So it has initiated the English instance. Okay, and that particular individual instance will be applied, right, as a tokenizer for the sentence whatever you have given. So tokenization is the first step in the NLP pipelines. That means for an AI agent, right, for AI agent, tokenize is the first step. Okay, so you can link like that one by one. So that is why only I'm explaining these concepts. Okay, so for an AI agent, basically the tokenization is the first step, because obviously the speech to text, that is a different area. Okay, so speech to text, that text it will start. Okay, so it will start that yes, I have to do something with the text. So that something, the first step is the tokenization for an AI agent, because it has to understand that what you have given, no, then only it can give you the reply. So for this much of process happens. Yesterday I was telling you, that these much of process happens behind an AI agent, and then you are going to give, you are going to get a proper reply from that. So this happens very, 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 very quickly, because all they are basically connected to a supercomputers which do the computation much faster. Okay. Now the next thing is the using the Hugging Face transformer. Okay. So here, if you see, we have gone through this transformer, this particular transformer application, because it's a framework. So we have discussed that also. Remember? So I told you also from GANs, VAEs, transformer, that same transformer only. Okay, and you can use. You have a particular feature called as a Hugging Face. You have a particular website also for Hugging Face. Okay, which basically uses the I can say transformer. Okay, and BERT also you might remember. Okay, BERT also I actually told you. BERT is basically a classification model which is used by Google. It is actually developed by Google, and which is actually developed, and I would say which is actually basically developed and interpreted, which is used by Google. Okay, so that is what basically BERT is actually. Okay, and we are going to use the BERT tokenizer in this instance. Okay, I wanted to use all the advanced technology what we have. Okay, so that it will be, okay, you'll get the feel that yes, I'm using I'm using the new things, right? That is very important for you. Tokenization portion, Kirisha. How AI agents actually yeah, because many people are not knowing the the NLP part of an AI agent. Yes, that is why only I wanted to touch upon that before going into the AI, building an AI agent. Yeah. Okay. So it's very important. Yes, 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 yes. I have to consider everybody and I have to move on. No? Yeah. So here we are using the transformers, especially BERT-based models. Okay. Uh, so that is why basically I'm using the transformers here, and I just wanted to also include the BERT model. So this is a very simple example, but my intention was to show you that how you can use a transformer. It may be a simple example, but now you have understood that how you can use a transformer, right? And transformer is built by Google. BERT is also built by Google. Okay, so these two are very important things you have to remember. All right, and for BERT, actually it will give IDs for the words. Okay, these are basically IDs for the words. Okay, so the normal NLP doesn't give this. Normal NLTK library doesn't give this IDs. IDs is nothing but the tokens for the words. So for a transformer, it is a 19,081 word. Okay, so they are defaultly trained in the transformer. These, it is like a name. I think you might be seeing this for the first time. You are thinking, what is this ID? Yeah, like how you and me have names, right? The words have IDs. Okay, so that happens especially in a transformer. Okay, so in a transformer, it is actually having that. Okay, yeah. So we'll actually go into a bit more detail also. I'll tell you some of the things also. Yeah, we'll see later. The next thing is using the naive Bayes model. Okay, so one more model we are going to use. Okay, and we are taking bit of a bigger sentence this time. Okay, so wait, yeah. So let us take a bigger sentence. Okay, yeah, should be fine. Now what I'll do is wait, just move this. Yeah, should be fine. Okay. Yeah. Right. So now you can see that I'm using one more. I've taken a bigger sentence this time. Okay. So I've taken a bigger text. You can just read the text. Okay. How can I think you have not understood? When I explained about the link of NLP, especially the concept of tokenization, how you can use it in the real life situation. Okay. So you and I will not use that in the real life situation. It is what the agent uses. What you will do by tokenizing the words, Diveshri? I think I told you yesterday. I was explaining in detail. See, okay. So if a few people might be having this doubt. Okay. See, what is the use of doing a tokenization? Okay, in a very simple terms, I'll tell you. Here you have seen one big sentence, right? So natural language processing is a subfield. Let us say this is a review. Okay. Let us say this is a review. Okay, review. That means a Flipkart review or an Amazon review. For a product review, let us say, whatever the e-commerce website may be, it is a product review, let us say. I bought some product review and I have put it here. Just for understanding, just think like that. So what is the use of taking a product review? First tell me that. Why companies use product reviews? Tell me. To understand strip pass. It's not strip, it is split function. That is with the basic Python, man. Don't go back again. I'll tell you. I'll just give me a minute. Okay. We have bigger questions. Please just explain that. So see here clearly. Let us say this is a review. Okay. Why you want to take a review? Tell me first. You want to analyze about the product, whether how people are feeling about the product, right? So that is basically product analysis, right? Or you can say sentiment analysis, that how a particular person feels about the product, whether particular person in the sense a group of people, whether it is a positive product on the negative product on the product, how people are feeling about the product. You don't want to analyze. You want to analyze, yes or no? Yes. Every company wants to analyze this, correct? How people feel about their products, right? So as a part of that, right, they take a product, right? It's not individually a group of products. Okay. So a piece of text, which is analyzed, okay, by using NLP, okay, and these agents will actually break down the words in a sentence, okay. So what is that sentence? Sentence is nothing but, in this context, it's a review, okay. How? Because in a very simple way to understand, an AI agent cannot understand your reviews or cannot understand a sentence. Okay. So what it will do is it will break down the sentence into words. That is only tokenization. And it will remove the stop words. That I will tell you also. I will tell you the stemming part, lemmatization part. I will tell you the what is stop words, bag of words, then parts of speech tagging, n-grams, all these things an AI agent uses. That is why only I'm trying to tell you that. Okay, yeah. So now this AI agent, it breaks down the review into words. That is only tokenization. Okay, and it will remove the unnecessary words. For example, such as and, as, okay, here and again, then is, so it, okay. So like this, it will remove. Those are basically called as stop words. I'll tell you that also, because only lemmatization, sorry, tokenization and stemming only I told yesterday, and session got completed. So from stemming and tokenization and stemming only I told. I have to start from lemmatization. So lemmatization, stop words. I'll tell you once this practical part is over, I'll go to that again. The theory part I'll go and again come back to the practical part. So it will break down into sentences and it will remove the stop words, which are unnecessary words in the data. And don't say again that, sir, how does it know that what are unnecessary? It is, the model is trained like that. It has been fed with words which the, with, okay, and is, the, as, it. These are stop words. So these will be removed so that the sentence will, from, if it is this much sentence, it will come down to this much. Okay. Then each word, it will try to understand context, that why or what that particular word is existing. It will try to understand that. For to understand each word and their context, we are using a transformer architecture. All right. So first of all, it should basically understand the words, right? And the context. So first, to do that, it needs to do the tokenization first. Then it does stemming part. In an order I will go, because it will be easy for you what an AI agent does. Okay, it is very important. I think now it will have been very clear that what a tokenization actually does. All right. Now, though I can say, for an AI agent to understand what you have asked and to reply you back, I can say tokenization is a baby step. It is a baby step for an AI agent. Okay. So because I'm talking in an AI agent language only, because AI agent only uses the NLP. Okay. So, you should be understanding that. So, that yes, it breaks down the words. So the first baby step, I would say, it's a baby step only. What what an AI agent does is basically, right? Yeah, good. That's why only I see you have asked. Probably many people also would have had the same doubt. So even I felt that yes, okay. Let me again try to just refresh your memory for today. Because this one I wanted to do it yesterday itself, but time was not sufficient, so I had to, that's why starting I started with the practical part. Okay, yeah. So now let us first use the method now. Okay, and yeah. So now what we'll do is we'll use the normal Python, okay, native Python, to do the tokenize. Okay. So native Python is basically nothing but, oh, you're asking this strip function. Okay. I was, because I didn't nowhere I have done the strip function where you are asking. I was thinking. Just a minute. Something is irritating me. Okay. So what is this dot here is, it's a delimiter. Okay. So it's a delimiter, and to divide on the basis of delimiter is what the split function is. Now, what is this strip? Okay. Now, what is this strip function basically is, if there is a space, okay, between the words, between, for example, not here, okay, you can see space between natural and language, that is common. Okay, so if there is a space between the quotes and the sentence, okay, so that particular space will be removed by, okay, strip function. So strip, for example, I'll tell you one, I'll just take one word, okay, wait, so I'll take this, okay, so I'll just take this example. Let us say natural language processing. There are codes. Okay. So if the sentence is like this, no need to use the strip function. Okay. For example, let us say here there is a couple of spaces. Okay. And here also there is one space. Okay. This empty spaces between, at the starting and at the last. Here you can see the empty space. No, this will be removed. Okay, between the words it will not remove, because it is supposed to be there. If it is removing between the words, it's an error. Okay, so at the end here you can see that one space was there, it has removed, and here you can see a couple of spaces that will be removed. That is the job of a strip function. Strip will remove the empty spaces at the starting as well as at the last. Okay, yeah, it's a basic Python function. It's not related to NLP or something like that. It's a basic Python function only. It is used in basic Python. Okay, yeah. So next thing is, the next thing, what here it is actually divided. Then next is using the NLTK toolkit. All right, and using the NLTK, here you can see that using the pumped and applying the sentence tokenize, and we are applying this bigger sentence, which is the text. Okay, and it gives you that natural language processing, and this is sentence tokenizing, and the words tokenized, you can see that it has divided, okay, into multiple words. So the same text only I have used here, the same text what I've used here. Okay, it's a bigger text. Okay, so example is just on the bigger text. Okay, so the application is the same, which is the sentence underscore tokenize and word underscore tokens. It's the same thing. Okay, only thing is, the only change what I have done is the increase the sentence size. Apart from that, that's nothing I have done. All right. So next, let us go to the next one, which is the one of the industrial models. Okay, because Spacy is what a lot of people use. Okay, and this is also one of the strongest models. So here you can see the the model. Okay, the same thing only we have done before also, English core web and SN. Yeah, it's the same thing, and the same text I'm taking here, and I'll be getting this tokenizer. Okay, so you can see that it is basically giving the sentence tokenize and the word tokenize here. Okay, so it is dividing into multiple words. All right. Okay. Next is using a Hugging Face transformer. Okay. So again, it's the same thing. What it has done, but the only thing here is we are using the bigger text. Okay. So I've taken a smaller text and a bigger text as an example. Okay, to show you the differences. Okay. So this is using the BERT tokenizer. This BERT tokenizer is inside the transformers. Okay. Yeah. Next thing is, yeah, to display the plots. Okay, so to display the plot, we are going to use the matplotlib. Okay, so many people would have actually been aware of. Okay, so matplotlib is nothing but a library. Okay, for building charts. Okay, so matplotlib is basically for building charts. Okay, So we have a couple of libraries in Python, which is matplotlib and cbon. Okay, so matplotlib is basically used for basic charts and visualization, and cbon is basically used for all statistical visualizations. Okay, and especially if you see the most appeared word, most common tokens is what I have taken. Okay, yeah. So you can see brackets, full stop also, because we have only applied tokenization. When it comes to reality, it doesn't only apply tokenization, it also applies the stemming, lemmatization, parts of speech tagging, bagging, stop words, everything it will uh, apply simultaneously. Okay, so that the model will be fully filtered out. It is basically like data cleaning only. In a very simple way, if I have to tell, in a data language, it is basically data preparation and cleaning only. But in a different way, because this text data is an unstructured data. So it is not like a table, kind of data. So it's basically a unstructured data. So this unstructured data has its own way, basically of cleaning the data. Okay, so that is why we are using things like tokenization, stemming, lemmatization, bag of words, parts of speech tagging, right? Stop words, n-grams, TF, IDF. Like this, we have multiple things which we'll be using. Okay, so it is different because it's an unstructured data. Methods in unstructured will be different from the structured data. So this is what the difference between a normal to the, yeah. And here you can see the most frequently repeated words which I have taken. And here you can see that this comma has been repeated 5 times. You can see in the diagram also. And is repeated 3 times. See. Okay, and next is plotting the most frequency. Okay, so again, you can see that I think this is the same thing only. I can remove this. I don't know why it has come 2 times. Okay, let me keep. I think I have removed a few things. Okay, yeah, let it be. No issues. So that is what it is. Okay, so if I run again, it will it will generate all the outputs. Yeah. All right. So I'll download this. Okay. So I'll be sharing that with you. Okay. That is for tokenization. Okay. Next is the stemming part. Okay. So let us see the stemming part. Okay. So the first thing basically we are going to apply is the tokenization. The second step is basically, okay. So I'll do one thing. Wait. I'll just put it that first step is tokenize. Okay. So it will be easy for you to wait, I'll delete that. Okay. And now I'll download. I've deleted that. Yeah. So it's better I'll keep one dot because you'll be remembering that first step. Anyway, in the PPT, it will be in an order only. But yeah, it's good for you also that you'll be able to, yes, I have to practice this first and then. Yeah. So the second thing is what is stemming. Okay. So the second thing is basically stemming. Now stemming is nothing but cutting down the word to its root form. Okay. So yesterday we have discussed that there are 3 kinds of stemmings, right? So I think you remember Porter stemming, Lancaster stemming, and snowball stemming, right? So these 3 stemming tools we are going to use now. Okay. So we are going to use those 3 stemming tools. Okay, and we are going to apply the stemming. Okay, and as usual for tokenizing, we are going to take the word tokenize. Okay, because we have to apply the tokenize and then we have to apply the stemming part. Okay, so together if I club into one thing, it will be confusion for you. So if you go step by step, it will be easy for you to understand. So that is why instead of putting everything into one, okay, so I have put into separate multiple Python files. Okay, that will be easy for you to grasp. Okay, so because the first step is tokenize, after doing tokenize, you have to apply the stemming part. Okay, So now this is the text. Okay. So here. All right. So this is the text what we have. Okay. And now we are going to apply all the three stemmings. Okay. So these three methods will be inside dot stem. Okay. It will be inside dot stem. And as usual, punct as well as usual using the word tokenize. So this is already part of the drill. Okay. Habib, clearly now I cannot. Please wait. Okay, I'm in the middle of something. So right. So we just applied this punct, okay, and punct underscore tab. Okay. So we are applying this along with the stemming part. And the first thing we are basically doing is the word tokenize. Okay. And then we are going to apply all the three. Okay. So for the first one, which is the Porter stemmer. Okay. So for the Porter stemmer, you need not give any default language because the default language for a Porter stemmer is English. Okay. But for the Lancaster stemmer, also default is English. But for Snowball stemmer, it has multiple language support. Okay. So that is why if you are using, even yesterday, even yesterday, I was telling you that, okay, that Snowball stemmer has multiple, I shared you the PPT also, guys. So Snowball stemmer is basically having multiple languages. So you have to mention which language you want. Okay. And you can see the difference between the stemming part. So for studies, you can see the Porter stemmer has put it as study, Lancaster has put as study, and this is this. So what happens is it will cut the word into its root form. Okay, I've explained already stemming. Actually, yesterday itself I've explained. Again, I'm not going back again what I've explained. Okay, so again it will take a lot of time, coming here and there and all, because tokenization and stemming I've explained actually. Then we had to close out the session. Okay, that was the thing which we have done last 15-20 minutes or so. So basically bringing each and every word into its root form is basically called as a stemming. So you can see that what is the original word, and when you apply the Porter stemmer, Lancaster stemmer, and the Snowball stemmer, what happens to the word? Okay, so it will come down to original form or the root form. Okay, so you might sometimes feel that whether the word is understandable or not, that is how stemming actually applies. There are actually a few flaws when it comes to stemming. So these flaws are basically, fixed or sorted out, I can say, by lemmatization. Okay, so once this stemming part is done, we'll go to the theoretical part. Okay, so 2 or 3 concepts, we'll see the theoretical part. Okay, then we'll come back to the practical part again. Okay, so I think, yeah, another 3 things we can cover. Time will be sufficient. Yeah. So next thing is the, once we have done that, now let us take a larger text. Okay. So let us take a larger text and let us try to tokenize as well as apply the stemming part. Okay. So now here you can see that for tokenizing, we are using the word tokenize as well as the sentence tokenizer. Okay. So we'll apply the word tokenize as well as the sentence tokenize. And for stemming part, you are going to use the Porter stemmer, Lancaster stemmer, as well as the Snowball stemmer. Okay. So this part is absolutely same what we have done before. So the text is this. It's a bigger text what I have given. So basically the bigger text is called as corpus in in the language of NLTK. Okay. So basically it is called as a corpus. And we are applying the word tokenize. And after that, we are applying the Porter stemmer, Lancaster stemmer, and the Snowball stemmer. okay, and we are printing since the sentence is bigger, okay, the words also, the table will also be bigger, okay, right from the basic things. So if you have applied the stop words, okay, stop words also, you will not get words like and, have, and, for, the, right, to, uh, you know for also will go to, like all these small words which are stop words, it will not come. Okay, so that also we will see now how it is applied. So now you would have understood what is tokenization first, and after tokenization, how to do the stemming part, right? So that is the second thing which we are able to do. Now the next thing is you have something called as a counter. Okay, so here you can see one such thing as counter. Counter is inside the collections module. Okay, so this counter function is basically applied for the potter stemmer. That means like the function is stemmed using the potter. Okay, and here you can see that you can count the number of words. For example, between word is appearing one time, process is coming one time. Okay, so like that you can identify which how many words are coming. Most commonly, so the top 10 common words which are coming in the sentence is what the counter function will do. So you can give top 20, you can give top 30. Okay, so this is the small example of stemming part. Okay, so I'll download this also, I'll give you guys. Okay, so this is about stemming and tokenization. Now let us go back to the first, because these two are the concepts which we have actually covered. Okay, which we have covered in in yesterday's session. Now let us go to the theoretical part. Let us have, I think at least some three models we'll cover. Okay, lemmatization, stop words. Okay, so whatever is in the order we'll cover, and then we'll come back to the practical part. Yeah. All right. So now let us see what is lemmatization. Okay. So after tokenization and stemming, the next thing is lemmatization. So lemmatization will or is designed to overcome the problem which stemming has actually. Okay, stemming is not a perfect model. Okay, so because of that only they have developed something called as a lemmatization. So what does a lemmatization do is it brings down to the dictionary form. Okay, not the root form like the stemming part. Stemming will just cut what is ever extra. So but lemmatization is not like that. Lemma means dictionary form. Okay, so it brings down to the dictionary form. So it is going to use the real world meaning and the real words. Okay, here you cannot see the real words inside stemming, right? So you can see study, which is having I, STUDI. Does a study have I, right? When it becomes studying, then it becomes I in the middle. But when it is just study, how can you have STUDI? So it is not possible. That is the problem of stemming. That is basically overcome by lemmatization. So lemmatization, what does it do? It bring down to the dictionary form, okay, and it makes sure that the word is actually having a real meaning. Okay, so that's what I have mentioned here. So unlike stemming, which chops blindly, it doesn't validate. Okay, so that is why stemming is much faster, because validation, checking, nothing is there. It is just cutting only. Stemming is just cutting, but lemmatization is not like that. So compared to stemming, lemmatization is a bit slower, because lemmatization will check with the dictionary words. Then only it is going to give you. So running will become run better. It will cut as Betty or Bet or something like that. It will cut if it is stemming. But a lemmatization will put better as good, was as B, right? So like that, it is going to change. So the real world examples that in search engines especially, he was running through the forest. So lemmatization will make was as B and running as run. So this ensures that it also retrieves he is running, he ran yesterday, he has been running. So all the possible combinations will be retrieved by the search engine, because it tries to map and match through lemmatization. So more accurate than stemming, which would reduce running to run, right? But in reality, RUNN is not there as per dictionary. That is what the problem of stemming. But lemmatization will bring it to run, RUN, because it will map, it will check. RUNN is not there in the dictionary. So it only has run. So it will bring down to RUN run. Okay. So that is how it will actually do. Next thing is email sentiment analysis. You can see she loved the products and wrote reviews. So you can see loved will become love, wrote will become write, reviews will become review. So help system identify core sentiments and actions better. Okay. Next is e-commerce product matching. So you can see that a user types I'm buying wireless headphones or earphones. So behind the scenes, buying will become buy, earphones will become earphone. So lemmatization improves recommendation systems and intent understanding without mismatching the different forms. Okay. Next is language translation. So the children ran home. Lemmatization will make ran as run. Okay. So ran will be kept as ran only if it isn't stemming. Yes. But that is what not this lemmatization will do. It will identify the dictionary meaning of ran, which is the dictionary form, which is run. So this allows translation models to find correct equivalent in other languages. Okay. So that is what like courier in French, maintaining tense and meaning. Okay. So this is how things will actually happen. Okay. When you're using a AI agent, this is what, there is a lot of, stuff what happens inside an AI agent before it gives you the result out. So next is chatbots and voice assistants. So I'm feeling tired. I've been working all night, the user says. So lemmatization will feeling will become feel, working will become work. The assistant would respond, would you like to, like me to play relaxed music? So to respond this particular sentence by a voice assistant, a lot of things happen, like the tokenization, lemmatization, stemming, stop words removal. So all the super duper hangama will happen inside, then only it will be able to respond. So this happens very, 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 very quickly. Okay. Next thing is text summarization. Okay. So documents contain, students studying, students studied, students study. So all are basically the forms of study only, if you see clearly. Study, studied, studying is only one form, which is study. And for students, students, everything, there is only one form, which is student. Okay. So that is what lemmatization is capable of. It is going to bring down to its original dictionary meaning. So improve summarization, accuracy, and reduces the word duplication. Word duplication. Next, let us, I think lemmatization you would have understood very easily because you have done the stop words. You have done the tokenization and stemming, no? So now I think lemmatization is easy to understand. So we'll see the practical part also in action. So now let us see some three concepts we'll cover. Then we'll go to the practical part. Okay, so that will be easy for us. Now let us see the what is stop words. Okay, so now let us see what is stop words. So stop words are basically most common words which do not carry any significant meaning. So I told you, these are basically removed during the text analysis. So for example, the stop words like the, is, in, at, and, and, of, with, all these things are stop words. So these words doesn't carry any meaning. So these are simply will make the sentence bigger or the tokens more. See, we need lesser tokens for the model to understand the context, that the transformer has to react. Okay, so react faster. If you have more tokens, it is very difficult. So that is why after segregating them into tokens, the next thing what we are going to do is we have to apply the lemmatization. Okay, and we have to apply the stops so that the tokens will become from this much to this much. It will be reduced so that the model has to understand very less. Yeah. So these words help form grammatical structure, but usually don't affect the semantic context of a sentence. So, many people might ask, sir, if you remove this, that is what the last line I've added. So if you remove this, the grammar will be affected, the context will be, for it to understand, it can only understand through words. it is easy for a model to understand than using the entire grammar. Okay, so to frame, to make it understand, we require to give, but it will be able to again structure it back. That's why it needs that grammar. But for understanding, it only takes the context into picture. So the real world examples is, best example is your Google search, right? So what is the capital of India? What is the of are the stop words? So this will be removed. What is left over is capital and India. So it will identify that capital India. So it will give New Delhi as the capital of India. Okay, so Google removes stop words to focus on the core content. That's what I was just telling you. So capital India improves search accuracy and the model performance and the perform. I can say and performance. Next is chatbots and virtual assistants. So the user says, "Can you tell me where my order is?" So can you, me, where is, everything will be removed because these are stop words. So it will only keep tell and order. So it will be able to figure it out. Yes, helps bot understand the intent, track and order by focusing on the keywords. So it will only focus on that particular keywords and it will be able to understand the context. Next is e-commerce search. So example, Amazon. Okay. So search input is shoes for running in the rain. So stop words like for, in, the will be removed. Shoes, running, rain. These only will be left over. So enhances the product search relevance and filters matching products effectively. Whatever is matching to that shoes, running, rain, in that particular products which are listed out, it will give you that particular products. So with the rather than the entire sentence, these three words will map it very quickly. Okay, so that is how it is going to retrieve the things very fastly. So you would have experienced this NLP in action, right? So you just search in Flipkart or Amazon, you get the results. No, that is natural language processing only. Okay, yeah. Next is email spam filtering. Okay, so this is the best investment opportunity for you. So this is the for you, everything will be left over. Best investment opportunity. This is left over. So don't you think this is enough for the model to understand that what is the context you are asking? It is sufficient, no? Yes, it will be sufficient. Yeah. So movie or product review sentiment analysis. I don't think the movie was really good. So I don't the was really. So it will be removed. Think movie good. So that is what. So hence NLP models focus on sentiment bearing words like good, bad, love, hate, etc. So that good word, even that think, right? So if it is movie and good, so it will feel that it's a positive sentiment. So here there is one more word which is think. That means she doesn't think it, I think so. So she'll be feeling that it's a neutral, it's a neutral review. It's not very bad. So she's saying really good. Just see that clearly. Okay, so that really is gone, but still the think word is there. No? So like that, it is going to understand. Okay. So it's just to make the model to understand faster. Okay. Next is healthcare chart systems. I need help with my blood pressure report. So I need with my everything will be removed. Keywords left are help, blood pressure, and report. So streamlines medical query and understanding. Okay. So this is how stop words are processed. Next, let us go to the parts of speech tagging. Okay. So lemmatization, right? Stop words, then parts of speech. These are the three things which we have to analyze. Okay, so we'll do one thing. Before going into parts of speech, we'll go for a quick break and come back. Okay, so I think if you have any doubts, you can ask me. Yes, yes, Habib. Yeah, good, good, good. Good that you have understood. Okay. Uh, so in the meanwhile, if you have any questions, you can just post it in the group. Okay. So if you just post it in the group, sorry, in the chat, sorry, I'll just answer your questions. Okay. So once we are back from the break, I'll take up your questions and then we'll go to the parts of speech tagging and then we'll see lemmatization, stop words, and parts of speech. All the three in action in in practical part in collab. Okay. So yeah. So exactly by 8 we'll go for a break. Okay. So I'm just waiting for the time. Yeah, I think it's 8. Okay. Yeah. So quickly we'll come back. Yesterday's one I should check, Achit. I'll share it. Okay. Along with today's Python files, I'll share it. Okay, PPD, Python file, everything I'll share. Okay, yeah. Fine. I hope you guys are back. Okay, yeah. Fine. So let us continue. Okay. So let us see this parts of speech tagging. Okay. Then we'll quickly go to the practical part. Saish, I think you have a question. You can just post it in the chat. Okay. So don't just raise your hand, please. Just post it in the chat. I'll answer your questions. Okay. So I'll definitely answer your questions. So the next thing is the parts of speech tagging. So parts of speech tagging is basically nothing but, yeah, it is basically about understanding the grammar. Okay, so like the noun, adverb, adjective, right? So I think most of you know the parts of speech, right? So why is it important in NLP is that the agent actually understands what in which context, which kind of situation you have spoken that word. So whether that particular word is a grammar, sorry, is a noun, verb, or adverb. So what is the situation? It basically needs that. Okay, so it basically needs that. So in that perspective, it is going to understand or analyze the parts of speech. Okay, so for example, the cat sat on the mat. So it will basically divide. Okay, DT is basically a determiner, NN is basically a noun, and VBD is nothing but a verb, and IN is basically a preposition. So like this, it is going to divide. So let us see some examples. So text to speech systems sentence will be the read the book. So is read pronounced as read or read? So whether it is present or a past tense. So parts of speech tagging resolves this by read will be the present tense and read which is the VBD. So which is the past tense as well as the present tense. So used in speech synthesis to determine the pronunciation based on context. So that is why only I told you when your assistant, your agent, will be saying that no, I have not understand the question. Can you, you know, can you repeat it, right? So can you repeat the question again, or can you, rephrase the question properly? Like this, it is going to ask you, right? Why? Because it needs that particular context in action, that particular framing of parts of speech. Okay, so this is what the main thing is. Next is chatbots and virtual assistants. So user will ask book a flight. So book can be a noun or a verb. So parts of speech tagging identifies that it is a verb based on the sentence structure. So this helps the bot understand user intent more accurately. That is why only you need parts of speech, especially for the NLP task for the AI agents. So next is the e-commerce search. So query is like green dress for party, green which is JJ and dress is for NN and party is for NN. The system knows green is a descriptive adjective. So improving product matching improves semantic understanding in search and recommendations. Okay. Next is grammar checking tools. So she go to school yesterday. Go is verb is grammatically incorrect with yesterday's past context. Suggest correction. She went VBD to school yesterday. VBD is nothing but the verb. So parts of speech tagging supports context aware grammar corrections also. So that is why only parts of speech is very important, especially when it has to break down the words and it has to understand the context. That is why it feels that each word's parts of speech is very important, and that is why it will delete the, you have to delete the stop words first. If you delete the stop words only, then you'll be able to put these things in a right order. Next thing is named entity recognition. So this is basically a pre-processing. So POS tags help determine whether a word is likely to be named, location, or organization. So this is a very important thing because name. We will also see this model, named entity recognition. So in this, basically, it will identify a company, a location, right? So it basically used for a classification thing. For example, like Apple is a company, but not a fruit. Okay, because even apple is a fruit, right? So if I'm saying apple, right, how it will know that it is a fruit or a company? So based on the sentence, other contexts, it is going to identify that apple is basically a company, what this particular person has given in the prompt. Okay. Next, yeah, named entity recognition, we will see later. Okay. First, we'll see those three. If time permits, we'll come to this. Okay. So I'll just share my. Wait, just share the screen. So first, we have to do the lemmatization. So let me share it. Okay. Yeah. And we have named this now. So tokenization, we have named it as first. Okay. And second step is the stemming part. Then third one basically is the lemmatization. Okay. So we'll name lemmatization as the third step. Okay. Because basically lemmatization is the third step. Correct? Okay. Yeah. And let me run. Okay. Let us start by understanding step-by-step process. So by now you would have understood the two important things. One is tokenization. The second one is stemming, right? And stemming is not perfect compared to tokenizer. Sorry, compared to lemmatizer. That is why we are using the lemmatization. So for lemmatization, we are going to use the word-net lemmatizer. Okay, so we are going to use the word-net lemmatizer, and for tokenize, we are going to use as usual the word tokenizer. Okay, so we are using the punct and punct tab that you are already aware of. Okay, it's not a new thing. The new thing here is the word-net function. So for this word-net lemmatizer, we are going to use the word-net. Okay, so this is basically for this only. Okay, for this. Okay, for this word-net is basically for the word-net lemmatizers. We'll do one thing. Okay, yeah, this should be good. All right. The next thing is using the word-net lemmatizer. So the function is basically the word-net lemmatizer. Okay, so I'm taking the word-net lemmatizer, okay, which I have defined here in the stemming part. So don't get confused here. The function is in .stem only because lemmatizer is like a part of stemming only. But there are two different models. You can think of lemmatizer as an upgrade model over stemming. Okay, so that is how you can actually remember what is a lemmatizer. So that is why lemmatization is also inside the stemming, like how the Porter stemming, Stovall stemmer, all those things will be there. So this lemmatizer also will be inside the stemming part. So the next thing here you can see that a text I have taken. So the children were running and had better grades than before. Okay, so I'm applying the word tokenizer as well. And here you can see that children has been formed into child, running is running, and is and had better grade than before is before. Okay, so still this will be simplified by using different models that we will go step by step. Then the most important thing is the parts of speech aware lemmatizer. Okay, so we'll go to parts of speech tag, but before this parts of speech lemmatization or lemmatizer is a very important thing. So here you can see that we are using the wordnet corpus, and then we are going with the parts of speech tagger. Then we are using the NLTK. Okay, actually this should be at the starting. Okay, so let me rephrase it. Okay. And next thing is the WordNet Lemmatizer. And then obviously our, the important person who is the tokenizer. And here we are using for the perception tagger, we are using, for the tagging part, which is the parts of speech tagger. We are, because you are already aware of this punct and WordNet, right? So punct is basically for tokenizing and all those things. WordNet is basically used for the WordNet Lemmatizer. So after that, for tagger, which is the parts of speech tagger, we are using the average perception tagger. Okay, this is for the English language. Next thing is the applying the WordNet Lemmatizer. Okay, so we are applying the WordNet Lemmatizer, and here you can see that we have given a sentence. Okay, and after lemmatization, we are also applying the tokenization as well. So you are also aware of that. Okay, and now see here in the output, you'll be able to see that parts of speech tagging also how it is going to give. Separately, we will see again. Okay, so whatever the kind of word it is, and you have the word and you have the lemmatized word, and in middle you have the parts of speech tagger. Okay, so NNS for child, DT for the, VBD for B, VBG for run. So like that you have that particular list. Okay, for what it is giving what. Okay, so if you want, you can change this lemmatizer here and POS here. So it's up to you where you want to tag it. Okay, and here you are using this tree underscore, tree bank underscore tag. So that is basically the variable which we are passing. Okay, so this define, you can see here, this is basically a function. So define is nothing but defining a function, and get underscore wordnet underscore POS is basically the function which is defined here. Okay, and here you can see that this tree bank underscore tag is basically the variable which is passed through this function. Okay, now after applying this, you can see that this is the original word, this is the lemmatized word, and you can see the parts of speech tagger in between. Okay, now let us go with the bigger text now. Okay, so let us go with the bigger text and try and focus on the lemmatizer as well as parts of speech tag. Okay, all right. So now let us see, we have taken a bigger text. Okay, we have gone with a larger text. Okay, let me run it again after making the changes. Yeah, done. Yeah. So this is the larger text which we have given. Okay, and we are applying all these particular things. Okay, all the libraries we are going to call. One is the WordNet Lemmatizer, then the WordNet. Okay, then the word tokenizer and the parts of speech tagger. So these are the four things we are not going to call. This WordNet is inside the corpus. So already we have done that. Next is applying the punct and averaged perceptron tagger, and then you have the WordNet. Okay, so all these things already we know what are those. Now the next thing is giving the WordNet. Okay, so this is a basic default WordNet. To convert the parts of speech tagger to the WordNet parts of speech tagger. So this is the basic or default function or code which is basically used. Okay, and next we are applying the WordNet Lemmatizer. Just understand the concept. Okay, so because a few of you might be from non-programming background also, just try to understand what it is. Okay, and next we are applying the word tokenize. Okay, then we are going with the Lemmatizer. Okay, so Lemmatizer basically cuts down. Now what happens is, we will see here that this is the original word. Okay, and this is the lemmatized word. In between you have the parts of speech tag. So you can see R is tagged as B. I told that this is not just like stemming. Okay, so it is going to convert into a root form. Okay, like not root form, like lemmatized form, like lemma. So which is basically the dictionary form, correct? So that is what this is basically going to do. So you can see multiple words because it's a bigger sentence. Okay, this is to and all, everything will go if you're applying the stop words also. So I'll show you that also. Okay, so this is basically the lemmatization. Okay, So if you are doing lemmatization, so this is what basically happens. Okay, so let me run it again. Yeah, I think it's fine. So I'll download this. I'll share you guys this. Okay. So this is about lemmatization. Okay. Yeah, it will be saved. So after lemmatization, the next thing what we have gone through is the stop words, correct? Yeah. So now let us go to the stop words. So before opening stop words, let us make this as fourth. Okay. So let us put this as a fourth one because this is the fourth step. Okay, this is the fourth step. Okay. So stop words is basically the fourth step. Okay. Yeah. And let me run this. Yeah, manage the sessions, please close tokenization, lemmatization, stemming. Okay. And run this. Okay. Yeah. So the next one here is the stop words. So this is a very important one because removing stop words is very important, especially to cut down or to bring down, to bring down especially, the bigger sentences into smaller sentences first. Sorry, smaller words first, which are tokens, right? So to bring down this, it is very important to use the stop words. Now, the first thing here is, yeah, it's compiling now. Just a minute. Yeah, now it's started executing. It will be fast on, like compilation will be very fast. Yeah. Okay, so the first thing here is defining the three important libraries. Okay, so the first thing is basically the corpus. Okay, for these stop words. Okay, because it will be inside the corpus. Then you have the tokenize, which is which to define the word tokenize. Now you will see the next thing, which is punct stop words and punct tab. So these are the things which you will be using. Next thing is the text. Okay, so which is a piece of text or a corpus, you can say. Okay, and next is we are applying the tokenizer. Then we are applying the stop words dot words is the function. So now what will happen is these are the original tokens. If you see, these are the original words. And in the original words, now you can see this is the filtered one, okay, with the stop words removed. Now you can see artificial is there because it is not a stop word. Intelligence is there. Transforming and intelligence, if you see in the between, is removed because is a stop word. All right. So is basically removed in this case, right? So it is very important, right, that it is a stop word removal. Okay. So industries is there, across is there, the is removed again. You can check because it's a stop word. I told is the even this full stop, it is in comma, everything will be removed and everything is removed. That is the power of using a stop word removal. Okay. Now going down, you can see that the next thing is we are taking a bigger text. Okay. Now I've taken the same example but a bigger text. Okay. Now if you see the same functions are only I'm applying. I've not changed anything. The same things. Okay. Here also the same thing. So I'll just put this one. Okay. Yeah. All right. So the same. This is done. This is done. Bigger text. Yeah. Okay. This one. Sorry. So here we have bigger text, and we have basically taken the same thing. Okay. And we have used the punct. Requiring the data and all. We have downloaded. Okay. So punct and stop words removal. Then comes the tokenizing the paragraph into words. Okay. And finding the length of the tokens. Okay. And after that, applying the stop words. We have to mention the language also on which the stop words have to be applied. Okay. So after that, the next thing is applying the stop words and punctuation. Okay. Now you can see that total words before cleaning, you can see total of 76 words in the sentence. And after the stop words are removed, the the total number of words has come down to 39. So now you can understand that is it easy to compile 39 words, or is it easy to model to understand 76 words, right? So unnecessary things like the stop words have to be removed in order to bring down the model and apply the model in an easier way. Okay. Next is the counter. So counter is basically used to count the values. Okay. So we are going to use the plotting part using the matplotlib. Now, since you can see here, we are plotting once the tokens are basically filtered. That means the filtered tokens. So these basically doesn't have comma, full stop, and the stop words like the, is, all these things are not there. So because of that, what will happen is it will only give the words which are important. So now you can see the graph that it has only the words. It doesn't have any stop words. Okay. So that is the use of removing the stop words. Okay. So I'll just run this again. I can share it with you. Okay. These are very small concepts. Easily you can understand. Okay. And for your understanding also, I have mentioned small examples also. Okay. So because I want you to learn very easily. It will be shared via. It is shared. You can check in the chat. Okay. So that is about the bag of words, sorry, stop words. Next, we have to do the parts of speech tag, right? So this is what. So parts of speech tagging is basically the fifth step. Okay. So till here, parts of speech tagging is the fifth step, correct? Yeah. So next we have to go to the named entity. Okay. So we'll go there. I have to explain that. Then we'll come back to the named entity. Okay. So let me explain that, then we'll come back. Okay. So fifth is basically parts of speech tagging. Let me. Okay. Yeah. So let us start. Okay. So the first important thing is basically importing the necessary libraries. Okay. So that is what which will be basically done. Okay. So Python is a programming language. Yeah, which is used for data science and AI and everything. Actually, I didn't take any questions also today. Yeah, I was actually busy in teaching these things today. Yeah, probably if you have any questions, you can just post it in the chat. Data science. It's a field of analyzing the data and building models and what happens in artificial intelligence, right? So it is almost a subset of AI. You can remember like that. Yeah. What is this 100.0? Abhi, I didn't get you. So any questions you can just ask me. Just ping me the. Actually, till now I have not given time, no, so that's why I'm asking. So if you don't have anything, I'll just forward. I'll move forward. Because parts of speech tagging you can complete, and also we can go to the named entity recognition also. Okay, that also can be done. Okay. So you want to build directly 100.0. That much talented you are. Wow, good. Then I should definitely contact you. Yeah. We can build together. Yeah. All right. Jokes apart. So questions. Yeah. Please be serious, guys. Yeah. Questions. Any questions till now? What we have done? We'll do with the parts of speech tagging. Okay. So once you don't have anything, I'll just take the questions. You guys started again posting the attendance. It will be posted by the admin. You have to just mark it, guys. That's it only. The job is to just mark the attendance and give the feedback. That's it only. Don't do anything else apart from that. Okay, so let me continue that. I think you don't have anything. Fine. So let me go to the next part, which is parts of speech tagging. Okay. And here you can see that these are the things which we have already used. It's not new. Okay. So already you have seen these things. The next thing is you can see a sentence, and then we are using the parts of speech as well as the word tokenizer. Okay. And once we apply this parts of speech tagging, it is going to tag, okay, with the parts of speech. So now it is giving different parts of speeches for different words. Okay. Now the next thing is okay. So printing in a different format. The same thing only I have done, applying the parts of speech tagger along with the word tokenize. Okay, along with the word tokenize, I have actually given. Okay, and now if we apply the word tokenize as well as the parts of speech tagging, you can see that each word is mapped to its parts of speech. Okay, so that is the important thing. Okay, yeah. Then next is basically reading from a bigger sentence. Okay. All right. So reading from a bigger sentence. Now you can see here that we are applying the word tokenize and we are applying the parts of speech tagger. So we are applying a very simple function which is POS underscore tag, that is basically parts of speech tagger. Okay. Yeah. So you can see the parts of speech tagging for the words right inside the sentence. Okay. Now let us go to the next part, which is for a bigger sentence. Okay, let's keep it like this. Yeah. So for again here, since we have multiple sentences, we are using the sentence tokenize and also we are using the word tokenize. Both of them we are actually using. And this averaged perceptron trigger already we have used till now, and punct also you are aware of. So for parts of speech tagging, we are going to use the POS underscore tagger or tag. So after that, the next thing is we are applying the sentence tokenize. Okay. And then we are also applying the word tokenizer. And we are also applying the POS tagger or parts of speech tagger. And here you can see that, okay, you can see that each sentence has its own, parts of speech. Each word has its own parts of speech. Okay. So here you can see that for each one, this is basically a bracket now. It cannot have any parts of speech, so it is not showing anything. Okay. So language, NLP, a noun. Artificial intelligence is a noun. So artificial is a noun. Intelligence is a noun. Okay. Focuses is a verb. DT is a determiner. So yeah, like that you have different parts of speech. Okay, so now let me go to the next part, which is using the counter function. So counter function basically collects all the or it counts all the things which are repeating multiple times in a data set. It's not about multiple times, it is about how many times it is basically repeating. Okay, so it is basically how many times it is repeating. That is what it is, right? So here if you can see in the output that NN is coming that particular parts of speech. So noun is repeating 9 times, And you can see verb which is repeating 3 times, determiner is 2 times. So like that we have individual repetitions. Okay. Now, so whatever we have actually distributed or found out in the parts of speech tagger, we are plotting it as a graph. So you can see that the most repeated item is the noun, which is NN, which is 9 times it has repeated. Okay, so that is why you can see it in the graph. All right, so that is about the parts of speech tagging. Now we can just go to the named entity recognition also. I hope you're understanding because I'm just going a bit faster. Okay, I hope it is fine for you to understand. Anyway, I'll share this. Okay, why I'm going a bit faster is to make you to understand a few things. Okay, because we have a lot of things to cover. So if you're not understanding any particular thing, especially you can probably ask me. Okay, don't worry too much. You can ask me. Okay, I'll just clarify. Okay. Yeah. So parts of speech tagger is also done. Okay. Next is the named entity recognition. But before going into named entity recognition, first of all, we have to go to the theory part. Then we'll go with the named entity. Okay. So let me share my screen. Okay. Share the PPT back. Okay. So this parts of speech tagging we have seen the concept as well as the practical part. Now let us go to the named entity recognition. This is a very important and a very easy thing only. Okay, so it is very easy actually, especially in identifying, the entities. For example, like any certain, companies, certain dates, like that. So these are some of the things which this named entity recognition will actually identify. So it will identify the person, it will identify the organization, it will identify the geopolitical entity, it will identify the date. Okay, it will identify the time, it will identify the money, it will identify the percentage, it will identify the product, it will identify the event. Okay, so all these things were basically identified by this uh, this named entity recognition. Okay, and this is what it's basically is. Okay. Next is, let us see some few examples. Okay. So e-commerce customer reviews. I bought iPhone 14 from, yeah, I know we are in 16. Okay, I just put it. Okay. So I bought the iPhone 14 from Amazon for, $999 last week. So here the NER taggers is the iPhone 14, right? Or 16, you can say. It is actually a product. Okay. So it's a product. So according to NER, which is named entity recognition, it is a product. Then Amazon is an organization. Then $999 is a money, and last week is a date. Okay, so like that it is going to extract. I will share Kirti and Pallavi. I will share the PPT. Still class is not over, guys. 44 only. You started asking no more. I'm sharing no every day. Only I think once or twice I forgot. I'll share. I'll share. Along with the Python files, I will share. Yes, yes, yes. 100%. Okay. So here you can see that the use case here is the external product names, brands, and prices. All those things can be considered as an example. So travel booking platforms. So book a flight from New York to Paris on August 10th. So the name entity recognition tagger is New York and Paris, and the date is August 10th. Okay, so automatically extract information, destination, and travel dates from the queries. Okay, next thing is healthcare and medical reports. So patient was prescribed 10 mg of atorvastatin by atorvastatin. Bastard. Okay, so and I just kept it, and I just picked it from somewhere. I just put it, it was kind of interesting, so I just put it by Dr. Smith at Apollo Hospital. So the tagger will identify the person as Dr. Smith, organization as Apollo Hospital, quantity as drug, okay, which is atorvastatin, which is 10 mg. So the use case is extracting the drug names, doctors, dosages from the clinical records. Okay. Next thing is news summarization. So OpenAI launched GPT-5 in San Francisco in March 2025. So the tags here is OpenAI, which is the organization, and GPT-5 is the product, and GPE, which is the San Francisco, right, the city. Then the date is March 2025. So the use cases automate event tracking and entity profiling. Next thing is legal document processing. The agreement was signed between Apple Incorporated and Government of India. So the NER tax is Apple Incorporated and Government of India. So the use cases identify involved organizations in the legal contracts. Okay. And we have one more important concept, which is the one hot encoding. Okay. So let us we'll do one thing. We can see this tomorrow. Okay. I'll just go back to the named entity recognition. Okay. So, okay, I'll just share the Python screen. Okay. So named entity recognition till there we'll do. Okay. So I have questions here. Guys, don't tell text, Svara. No problem, no problem. I've shared the 5 Python files. Okay. This is IPYNB file. So there are two ways to import these files. Okay. Two ways to use. If you are using Jupyter Notebook, you can import this into Jupyter Notebook and you can view. And if you are not using Jupyter Notebook, you want to view it in Colab, let us say, like how I'm doing. You can just open your Google Drive, copy this, yes, I'll give Achit. So copy this particular, into your Google Drive. Okay. So for example, anyway, I'll show you that also 5, 5th. So yeah, 6th one I have to show you also, correct? Yeah. So named entity recognition. Okay. So how you can actually do is you can create a folder like this. Okay. You can put all the IPYNB files. Okay. And you can open it. If you double click on it, it will be open like this in Colab. So this will be opening in Colab if you put it in the Google Drive, because Colab is from Google, no? So if you put in Google Drive only, it will be opening in Colab. Directly don't double click and try to open. You cannot open in normal Windows. Okay. Yeah. Right. So let us see this named entity. So till 6 we can complete. Okay. So 5 I've already shared. The 6th one also I'll share it. Yesterday's PPT also I'll share. Sir, it's not come. You cannot double click in your computer. It's only download and put it in your Google Drive. Put it in your Google Drive and then you have to double click on it and open. Okay. So it will not open in your normal computer. Phone, it will not open at all. In phone, it will not open. If you want to open in phone, you have to put that file inside your Google Drive. You can only put it in your Google Drive and you can open. Okay. Or you can import into your Jupyter Notebook if you are using Anaconda Navigator. Okay. Yeah. Yesterday's also I'll share, but let me finish this. Okay. So okay, so let me first discuss this. Okay, I have to share the 6th file as well as the today's PPT also. Both I'll share. Please give me some time. So first let us see this for named entity recognition. So you can see here that we are using the Spacy model. Okay. And here you can see in EN English, it's the English. Core is nothing but for the pre-trained model, and SM is basically for the small model. So I already told you that. PDF. I have not shared any PDF. That is not PDF. That is a Python file. Sai Kumar, it's a Python file. You have to put it in your Google Drive and you have to open. It will not open. It's not a PDF. It's not a PDF. It's a Python file. So it will be in the format of IPYNB. If you see the extension as IPYNB, it's a Python file. It's not a PDF. Okay. So don't try to directly, you cannot open in Windows. It will not open. You have to put it in your Google Drive and then you have to open. Okay. So if you are sharing Python, you can only share by IPYNB file only. You should use the correct platform to open that IPYNB file. Okay. You cannot simply directly double click and open. It will not open. All right. So when you actually can see the Spacy, which is basically loading for the small models or medium or large models. You have the text with you, and then you're applying the pre-processing using the Spacy part. So if you are using that Spacy basically for identifying the named entity recognition, it is going to identify that here you can see in this sentence that Apple Inc. it has identified as organization, 5 billion as money, India as GP. So GP is nothing but countries. And date is 2025. Tim Cook is a person, San Francisco is GP again because it comes into the category of country, city, and states. So Monday is a date. So this is how it is going to identify the NER. So it's a way of identifying what is there inside the, sorry, I've not ran it. Yeah. Okay. So it's a way to identify how, basically things will be identified by the model. Okay. Now going to the next part, which is identifying. Yeah, just let me read it. I just ran it. It's executing. Yeah. So here you can see the this display C model. Okay. So it will identify what are the important things in the model. So you can see this. So even I just put this for that to identify. So Apple Inc. is an organization. It is important. 5 billion is money. India is GPE. 2025 is the cardinal, which is the number. Tim Cook is a person. San Francisco is a GPE, is a country or a city, and Monday is a date. So this is how you can actually show it. Next is we are going with a bigger text. Okay, so I'm just going with a bigger text. You can see that the same thing only I've done. Okay, so I'm just mentioning it as a bigger text. Okay, so wait, I'll remove some of the things before sharing it to you. It will be easy for you to understand. Okay, yeah. Okay, so now you can see the text what I've shared. Okay, so the same named entity recognition. All right. And here you can see from this bigger text, you can see, okay. Here you can see that March 14th is date. Microsoft is an organization. OpenAI is also an organization. Binge is a person. Okay. So this actually is identifying as a person. Okay. It's a search engine actually. Seattle is GPE, which is country and all, and AI is a GPU. Satyanadella is a person. 2 billion is a money. MIT is a company. It's an organization or agency or institution. Anything it will consider as an ORG. So the same thing I'm applying here, and whatever are important in that particular sentence, which is identified by using the NER, is shown like this. Whatever is important. As per NER, because it is using the named entity recognition. No, see for example here tech summit, emphasized. All these are also important. But according to NER, it is different because what NER is doing is different. What you are expecting is different. Okay. So next is the counter function. So counter function is basically to count the value, count. So here you can see 8 organizations, or 8 times the organization word is actually, repeated. Okay. So next thing is using NER for using transformers. Okay. So here we are using the NER using the transformers. So we are using the BERT transformer for this. Okay. And loading the NER. So we have given a bigger text. Okay. So now we are using the transformer. You can see that, if you have this kind of running of a model, it's basically a transformer. Okay. And this is the transformer. So Tesla is an organization, Evan is a person, Elon Musk, Berlin is a location. So like that, it has calculated. So here you can see that it has given the scores. Okay. So those are basically probability scores. How much certain it is in prediction of that particular thing is what the scores basically are. Okay. So that was about the named entity recognition. Okay. So let me just run it again. So that I can share it with you. Yeah, it's fine. Okay. So any questions? You can just ask me. So 5 I have shared. This is the 6th one. Okay, which I have just told now. Okay, and coming to the PPT part, I'll share it. So from one hot encoding, we have to discuss tomorrow. Okay. All right. So just give me a minute. In the meanwhile, you can just ask questions if you have. NER till NER will complete it. Guys, if you're using Google Drive, it will work. Okay. Don't say that the file is not working. Okay. So this is the day 9, right? So day 8 also, a few people were asking about the PPT. I've shared it yesterday. Probably you would have missed it. Yeah, I've shared it again. Okay. So any questions? Okay. Fine, man. We can wind up. I think there are no questions.
Yeah, sure, sir. Thank you very so much.
Yeah.
Yes, students, just a reminder, please mark your attendance, which I can see in the chat. Mark attendance. We are done for the day. Again, tomorrow 1 p.m. Thank you all. Right. Thank you for joining.